everybody. And for those of you who just joined, this is our webinar, Drive Enterprise-Wide Adoption of Your Databricks Lakehouse with Data Mesh, presented by Ascend.io. We're looking forward to a great conversation today about what Data Mesh is, how it is compatible with the Databricks Lakehouse, how it can encourage people to maybe migrate off of their older platforms and paradigms into the Lakehouse environment. And to do that, we've got a great presenter for you as well. So my name is Paul Lacey. I am the head of product marketing for
Ascend.io.
when I will be your host and moderator for today. And I'd also like to introduce my co-host, John Osborne. John has a long career in data. He's, I think, describes himself as a recovering chief data officer. Is that right, John?
That's right, Paul. Yeah, that's absolutely right.
Lots of experience in data mesh as well, John. So yeah, you want to introduce a little bit about your background, what you do here at Ascend?
Sure, great. Thanks, Paul. Thanks for the intro. I'm always excited to talk about data mesh, and in particular, data meshes on Databricks are super interesting to me. So happy to spend 40 minutes or 50 minutes talking through this and bring some road rash to bear and some opinions and talk through how Ascend might be able to help with data mesh too. Just a little bit of that if we can.
Awesome. Yeah, and for those of you that have questions as we go through the session here today, please feel free to put those in the chat, in the Q&A. We will be saving some time towards the end to answer any of those questions that might come up. So please feel free. The other thing is we will be recording this session, and a copy of the recording will be sent out, so you don't have to furiously take notes as we go through here. And as we were just talking about before, if you're multitasking, don't worry, you're going to get another shot at going through all this great material. But please do add any questions as we go along here.
Great. Yeah, I love the questions.
Awesome. Well, shall we get started, John?
Sure, let's go. And what I wanted to lead with before we get to the agenda slide is just a few interesting statistics about data-driven businesses in general. My assumption is if you're exploring a data mesh or you've heard about it or you're researching it or maybe you're in the middle of an implementation, chances are really good you're trying to help your business go forward with data. I mean, the current buzz is all about, ChatGPT and AI and ML and large language models and all of that. But if you take a step back, it's all about making businesses data-driven. And so here's some interesting statistics. The one on the left is from McKinsey, in that over the next decade, there's going to be a 250,000 person shortage of data experts, which is like that's crazy in our world. That's a lot of gap in where you want to be versus where you're at. And then I know we do a pulse survey every year. We've done it for years and years. And we do know that for the businesses we survey, like 95% of them are over capacity. So this means their backlog is longer than they can possibly handle. It's bigger. They can't get all the work done. And that most companies also believe that their data product needs is growing faster than their teams are. So they want to produce 3 or 4 times as many data products, but they're only getting maybe a flat budget, or they're getting maybe 10 or 20% more budget to hire people to actually do the work. So all of these factors are driving the need for not only strategies that are going to drive more business value more quickly, but also technology and automation that allows fewer humans to be involved to produce more things, because this is what's happening in the market. So I don't know, Paul, in your marketing research, if you see these kind of things, but I know I see this on a daily basis, talking with potential customers and with just people in my network too. It's pretty amazing.
Yeah, I mean, it's certainly reflected in the most recent version of the pulse survey that we did. And we're actually going to be showing a little bit of that data later on, John, which is super exciting. It's hot off the presses for the survey that we conducted this year. But yeah, data teams are definitely over capacity, and people want to get more done with less. And that's kind of the theme for the year as well, right? So if we think about what's happening in the broader scheme of things. But yeah, there's also a trend towards having people self-service more that we've seen in a couple of the surveys that we've run or that our partners have run recently. So, how can we get more people conversant with data, using data? And that's something I think we're going to talk about too, right, John, with data mesh.
Definitely. I'm a huge fan of non-engineers helping with data meshes. And real quick before the agenda, I just wanted to kind of hit this just for a second. So why is Ascend.io interested in mesh? It's not just because I'm interested in mesh, but Ascend as a platform lends itself super well to data meshes, in that we are an intelligent data platform that allows you to do the automation and the end-to-end work that you need to have in order to produce an effective data mesh in a cost-effective way, and with those constraints we just talked about. So like, there aren't enough people, there isn't enough money. How do you still get your work done? Ascend provides that capability, in particular on a lakehouse with Databricks too. So So from an agenda today, I know we went back and forth on this a little bit, Paul, but I'd like to hit these kind of four bigger topics. Like one is data mesh is a solution that can help you out in a large ways. Also talk about like if you're going to do a mesh, like what are some considerations and some watch outs and some good design practices for your domains and what to worry about, what to think about if you're moving toward a data mesh. Again, if you're going toward a data mesh, you're coming from somewhere. So we're going to talk about sort of the likely scenarios there. We're going to talk some about why Databricks is like a really great platform to put a mesh on in general and how Ascend helps with that. And then what about all your other data? Most companies, at least the ones that I talk to or have talked with, Databricks isn't the only database. There's other databases in their organization. Databricks might be the center of the compute world, and it may be the desirable place to put all of the governance and all those kind of activities. But what about all this other data that it might be out there? So let's talk about that a little bit also. So here's the agenda. This is the agenda I'd like to
You mean
go through.
enterprises have legacy technology, John? Is that what you're saying?
Oh yeah. Whether it's an on-prem data center or you have multiple clouds or you have like another cloud database that shall not be named today, where data exists and you need to move that or somehow reference that in your Databricks environment. Yeah, let's talk through that for sure. I mean, I think that may be the definition of an enterprise. Like if you have one Postgres database, you're probably not an enterprise. But as soon as you have Databricks and maybe a dozen other things like most enterprises do, you're probably an enterprise. But let's get started. So
Great.
real quick, just doing some basic research. And if you're familiar with Mesh, or if you're not familiar with Mesh, I highly recommend reading this Martin Fowler article. It's basically the origin of the thinking around the term data mesh and how it came to be. Some of it's kind of technical, and some of it kind of gets down into the weeds. But Zermatt is basically credited with coining the term and then driving a bunch of the strategy for data mesh. But if we want to summarize data mesh, at a high level, it's really a composition of two things. One is bringing a product mindset to your data. So Paul, to your earlier point, this is getting the data approachable so that it can be actually used and shared and then consumed into multiple data products from the business standpoint, whether those products are reports or actual maybe apps or insights or however you're going to consume that data. Product mindset helps us bring that data more readily toward people who maybe aren't well-trained engineers. There may be just business people who know a little bit. So maybe we can use product mindset to help there. The second concept that builds a mesh is making sure that we're organizing the data in terms of data domains. The technical term is a bounded context, but this means that we're going to maintain data in groupings that make sense for our business, and we're going to match up those groupings with how our business operates. And then we're going to, as data engineers, we're going to help solve problems like how do I generate a customer list out of my bounded context. So how do I have a customer for a shipment and a customer for maybe a marketing activity, and they came together in different ways? So how do I design a data environment that services all those needs with all those different shapes of data? And of course, the term we're going to use today for that is data mesh. So when we say data mesh, you can think of like this maybe woven thing. I'm not going to use the word fabric, but sort of this consolidation of all of these different contexts into a thing that I can then use for real value.
And maybe
And
that's a good thing to dwell on for just a moment, if you don't mind, John. Like the
sure.
difference between data mesh and data fabric, because in a lot of people's minds, I think they're interchangeable, but there are
Yeah.
some differences, right? Like when
Yeah.
you talk about data fabric, you're not necessarily talking about a data mesh type
No, you're
architecture.
actually not. Really, the difference between them, and there's tons of research out there, but in 30 seconds or less, a data mesh is constructed from these domains that you're going to engineer that match up with your business. So you're going to end up with like a finance domain maybe for your business that like has your finances in it. You might end up with a customer domain because you have a customer service department, so they have a customer domain. A data fabric is more about putting a layer on top of the data where it resides. That layer allows you then to query the data and figure out where your data is, and then compose data sets that you're going to pull out of your fabric that become useful to you. So if I'm going to ask a data fabric a question of like, hey, I want customer data and I want SKU data for this one SKU, go tell me where this data is, and then I want you to compose a data set for me. That's more of a fabric type implementation where I'm not actively pursuing a consolidation of knowledge into domains, and I'm more doing it at a metadata level and then querying it. So two different concepts, both servicing very similar outcomes from a business standpoint, but both implemented in totally different ways. So today we're going to talk about data mesh though, because it pertains or it overlays really nicely on top of Databricks, and especially with the help on top. So if we
Makes sense.
talk about like where you're coming from. So if you're looking at a data mesh, most people looking at data mesh that I've talked to across all of the talks I've done, they want to go faster. And what they mean is, I need to produce more data products for my businesses. I need to like not take 6 months or a year to produce this report. I need to get these times consolidated. I need it to take fewer people, and I need it to be less complex. So lots of people, architects, engineers, leaders who come to data mesh, they're coming from a monolithic data architecture. These are architectures maybe in a private data center, or somewhere where you have a monolithic data model and you're burdened by hyper specialization, either because your tooling is holding you into a single architecture or your data experts are few and far between. You have 2 or 3 people who know how this model works. Nobody else can figure it out. It's got hundreds of tables in it. Maybe I personally have had them with like 700 tables in a monolithic architecture. It's impossible to have more than a couple of people who understand all of that. And a lot of that's driven from maybe some legacy thinking about you know, normalized architectures that can be everything for everyone data models. These are very complex. They're very hard to build. They're hard to maintain, and they tend to get very rigid in design because they're very fragile. They're easy to break. They're hard to query, so we don't change them very much. And my rate of change starts to slow down over time. Every time I add a feature, I slow down a little bit more because I add some more debt onto this monolithic model. Data meshes, the promise of a data mesh, though, is a little different in that because I'm maintaining the ownership of the data in the area of the business or with closely aligned technical resources, aligning with the business, I can keep this data separate and smaller and assign the ownership to the experts for that particular piece of the business and not worry about building a whole model across the entire business. But now I have a different areas or regions of my data infrastructure where the expertise is consolidated, that there's less data in those regions, and then I can manage the ownership across them. It helps with things like prioritization. It helps things with agility. Then it can also drive approachable self-service when I do this too, because I can have data models that are simpler and easier to query and easier to document and easier to govern. So the promise of a data mesh is if I'm able to do these things on the right, it means that I can actually go a little faster, or at least not degrade every time I add something to my model. I can at least maintain a certain level of velocity as I go forward, for sure. Hopefully accelerate as you get better at it, for sure. So if we double click a little bit more onto data mesh, it's really ends up looking like a consumer-friendly paradigm. Consumer as in my data partners, my data consumers, my business friends who want to use this data. The data mesh is going to help us with these problems. So it's going to force me to have discoverable and shareable data. So if I have a data mesh and I have multiple data domains, one of the underlying assumptions of that is that I have to be able to discover where is my data and how do I share it? So if I have a customer data set and it's unshareable and you can't see it, but you need customer data, I don't have a data mesh. I can't drive self-service. So we need to like have shareability as part of the data set. The data also needs to be usable and approachable, and those sound really simple, but really what it comes down to is the language and the language we use to define these data models and the attributes within them need to be understandable by business people and by cohorts that are going to consume this data. Very often in the technical side, there's a conversion of business terms into column names that don't really mean a lot of things, and you can patch that with data catalog solutions or other software or levels of complexity. But I can also choose to make my data model actually business friendly too. So this is what we mean by approachability. Of course, secure is important, but the other two things, trustworthy and standardization, are also critical. One is expanding a data mesh within an enterprise requires trustworthiness of the data. If people don't believe the data is correct, or they don't understand where it came from and they're questioning it and they can't get answers, that's going to drive doubt into the data, and they'll be less apt to want to dive in and start to use that data. Standardization is also important. And one of the ways the standardization plays out is in how do I access the data? So if one data set is exposed with a REST interface, for example, and another data set is a SQL interface, that's not very standard. And so it's very difficult for me as a data consumer to join that data together and use it. So having standardization in a platform is key. If you're putting your data mesh in Databricks, it's all queryable. There's a query engine. Doing either Python or SQL, it doesn't really matter, provides some level of standardization there so that I can actually query the data. the next levels of standardization might be in naming conventions and some of my governance activities around how do I understand how to interpret this data, what are my business keys between my domains, and how do I standardize on all that information. And that's all governance. But if you pile all this together, now you can start to talk about having an actual data mesh when you've addressed these problems, either theoretically and you're off to the races building a mesh, or you have a mesh and you can check these boxes and say, yes, I have all of these things. That means that you'll have a data mesh for sure.
The other thing I find interesting, John, is that this entire list of attributes could also be applied to any product that is being created and sold in the marketplace. So you can imagine going into a supermarket and saying like, oh, everything on the shelf here, all these things apply, right? Has to be discoverable so that people will buy it. It has to be approachable, usable. You have to trust that if you consume this thing, it's going to be good, and it has to be secure and standardized. You can't be getting Fruit Loops when you're buying Cheerios, and stuff like that. So
yeah, I mean, I think it's really true in that lately, maybe in the past few years, data as a product is a real thing. And just because data is a little ephemeral and it's hard to see and it's not physical, like you can't pick it up like, like a box of, cereal. It is a product, and if we treat it that way, we also get the benefits of the product. So we get the feedback, we get the improvement loops, we get all of those things that we would get in any sort of product management scenario for sure. So data as a product is one of the key features of a mesh, definitely. The other thing that will happen with a data mesh is it's not just going to change the technical aspects of how the data is organized. It's also going to change the organization and how the organization operates. And this may or may not be obvious, but in order to get the benefit out of the mesh, you can't just have a technical solution. It's also got to have this business or human side solution that comes to bear too. So if you're in a monolithic architecture, for example, typical data work looks like this, where I have a data engineer. They're doing a bunch of work over long cycles for a bit of time. They quote unquote finish their requirements, they give it to a data analyst, and the analyst then does a little bit of work and puts it on a report, and they're done. So this is a lot like people or organizations who file tickets to get reports written by engineering. This is the opposite of self-service, and this is relying on engineers to do lots of things that really aren't engineering. They're more like data analysis, but because they're trained in the tools and in the monolithic architecture and in this sophisticated data model that very few people understand, they're then burdened by actually delivering data products out of it. We can't actually let the analysts touch it because they don't know how to use Git, or they don't know how to use the workflow process to deploy code and all of that. So we're hamstrung by these architectures and by the engineering required to manage them. If we put in place a data mesh architecture and we're doing it with tooling that allows more things to be true, a couple things will become really, really obvious in the organization. One is that development cycles will be a lot shorter. The engineers working on those deployment cycles will be more experts in the particular area that they're working on than they ever were across the entire monolithic model. So you can have an expert in the customer service data model because it's not very complicated. And you can have an expert maybe in your shipment or fulfillment data models because those aren't very complicated as they stand alone. But having experts across the entire business is almost a near impossibility for lots of companies. So focusing the engineering effort allows them to move more quickly and produce produce their outcomes faster. But it also allows then the data to be picked up from the engineer sooner. So notice the vertical bar here for the engineers is further to the left. That means that engineers can do less work, and then analysts can do more work. They can start to do things like actually build the report from the data mesh instead of having the report built for them, and then they're just QAing it, for example. They can actually do the report building. And then I can introduce even more cohorts of people. So more fingers on keyboard theoretically means more output. So now I can introduce data scientists who actually want the same data, albeit in maybe a different shape, but they want to take the data and they want to do some interesting, AI or ML stuff with it, or do some, voice to text, whatever they're doing with their data science activities. So the data mesh architecture in the org should feel dramatically different, even down to the number of people in meetings should be smaller. The meetings should be shorter, they should be simpler, and there should just be, in general, better documentation across the entire enterprise because the models are simpler and smaller, for sure. So before we go too much further, let's talk about companies who are feeling the need here and who are talking through some of the statistics around what they're planning on doing. So in this pulse survey, Paul, this is the 2023 one. This is very, very interesting that a ton of people want to implement data mesh architectures. I think there's a ton of traction for it. And it's also interesting to me that well, smaller percentage, only 20% is already doing it, and you have almost 60% or almost 70% going to do it but haven't started yet. Does that make sense to you,
Yeah.
Paul?
Yeah, it does. I mean, it's been a buzzword in the industry for quite some time now. Ever since that article came out, when was it, John? Was it 2018, 2017, something like that?
Hmm.
Through the pandemic, where this really kind of caught fire as a buzzword.
Hmm.
We've seen some pretty dramatic shifts as people, really start to lean into this. And we do ask this question in a specific way because there are some crossover, and some people, use the term data mesh, some people use the term data fabric, which is why, we have to clarify sometimes when we're talking
Hmm.
about this. One's a technology first approach, one's a organization first approach. But kind of lumping those two things together, we do see that this decentralized organization of data is accelerating across the business. And I think in the next slide there, John, you can actually look at what it's doing year over year,
Hmm.
where you can see, yeah, the number of people who plan to implement data fabric or mesh within the next 12 months has grown by
Hmm.
6%, and as well as the number of people that have implemented or say they're already using a data mesh, data fabric type network approach has grown by 10% year over year. So I think we're starting to see the wave crest a little bit here, which is
Yes.
fascinating.
And it's actually interesting data chart thing, right? So it's grown by 10%, but that's 10% across the whole cohort. It's actually grown by 100%. There's almost double the amount of people using a data mesh or data fabric from one year to the next, which is still only 20%, but that's a pretty big gain there for sure. And I think the other one that's interesting is almost nobody moves away from it. So once they go to a data mesh, for example, they tend to stick with it for sure. It ends up as a better place to be. I think you grow out of your monolithic world and you need this data mesh fabric thing. And once you're big enough to go there, you're going to stay there for sure.
Absolutely.
I think we
Yeah.
have a couple more. We have a couple more slides though. And then this one is like, will it actually help on the consumption side of data? So I think one of the main problems that data mesh solves, or the solution that people are seeking when they're looking out data mesh is like, hey, I have all this data, and we keep doing stuff in engineering from the engineering side, but nothing happens on the business side. They're still wanting more reports, and they're still like not using enough data, or we're underutilizing all the data we have. And I think data mesh is one way that folks are um, definitely thinking through getting more value out of the data they already have. So,
Yeah. It's interesting too, if we double click in here, John, with I think the next slide looks at the spread of the roles of people who are responding here.
mhm,
And it's interesting, data executives are really all in on data mesh,
mhm,
with over 50% of them and their direct reports saying they strongly agree that data mesh or fabric will enhance the use of data across the organization. So you look across the chart, there's a few bars that stick out here. Maybe some individual contributors can't see the forest for the trees sometimes in some of this stuff.
yeah,
But
yeah, yeah,
but on the whole, it is a very top down kind of executive level initiative that we see kind of rolling out across these organizations. And I think the other thing that we can take away from this is that the individual contributors, that the team leads, the kind of folks that are mired in the day to day. Hope is there. Like there's a light at the end of the tunnel.
hmm,
You can see that with this level of executive support, we can definitely expect a lot of these programs to start getting some traction over the next 12 months.
hmm,
And if there's one thing that you were just talking about, John, is that individual contributors' lives will get easier once the mesh is implemented, right?
yep.
So we can there's hope, there's light at the end of the tunnel there.
Yeah, I think so. And I think, oftentimes the strongly agree that's low for individual contributors and team leads reflects maybe a little skepticism that the leader is gonna actually execute on the model, because it does take some intestinal fortitude to get a mesh across the goal line, not just technology wise, but from the business side to actually drive that self-service and like demand self-service from the business. Like, hey, we're building this thing, you need to use it, so you have to do your part, which is come get trained on how to do a little bit of data work, and then come and actually use this model. So I know I've been there a couple times, and it's hard work for sure. Absolutely.
That's great.
So love the statistics. We're all data people, so that's fantastic. Um, I think as we move on here through the discussion, I think and this is a good segue into, if we are going to be changing our org and we're putting a mesh into place, and we're going to think through like, what does a data mesh do for us, and how do those things play out on the business. I think it's really important to talk about old paradigms that we may be coming from. So if you're coming from a monolithic model, or you're coming from something that is just really hard to work with, so you want to do something different, I think it's really important to understand some of these biases that we bring forward into our models. And one is, when I hear this all the time with data mesh comments, is like duplicative data is going to cost me more, right? I've been trained my entire career that I should have a normalization model that like eliminates all the duplicates. So there's no duplicate. I have one table that has all my customers in it and it's all perfect. I call that full normalization bias, right? Or the second one, I want or need a single source of truth. So I need a single table that shows me the data that is a source of truth. And this is ignoring customer need bias, I call it, because different consumers of data have different sources of truths for what actually matters to them and what their business context is. So it's important to like let those business contexts play out in the models so that they become really valuable and therefore trustworthy for our business partners, right? And then, of course, the last one, which is near and dear to my heart, is my scheduling of all these jobs is too complicated. So I want fewer schedules and fewer pipelines. I want more of them, fewer bigger ones to manage. Sorry. And I call this an imperative design bias. I want to have like one schedule that does everything instead of a whole bunch of little things that actually do the right thing. And I think the kind of the solution to these paradigms as we think through them as we're moving to mesh and likely moving into the cloud too, if you're thinking about a mesh, or if you're already in the cloud, you're at least changing your mindset from monolithic, maybe private data mindset in the cloud to like actually cloud usage. There's some truths in the cloud that we should be aware of and we should design for. And one is that storage is less expensive than compute. So having a bunch of data sitting in the cloud doing nothing is way, way less expensive than taking a large data set and continually computing the same answer on it every day and wasting credits on compute. So I think storage is something we should leverage to our benefit for sure. I think Delta Lake on Databricks really helps with that a lot, especially with these super high compression ratios you can get. It's also true that simpler data models use less compute. So if I have a giant normalized model that takes a dozen or 2 dozen tables and a really sophisticated join criteria to produce an outcome, if I physicalize those outcomes into simpler data models, that is going to consume less compute, albeit at the cost of maybe more storage or maybe more orchestration requirement to build it. It will cost me less in the long run. And so if we take these first two things and we sort of make a general conclusion, it means that more simpler data models should have a lower total cost of ownership than my old monolithic single model. And this plays directly toward mesh. And I think if you pull the technology way and you start to look at the financial side or the financial operations side of data meshes, this is playing out in spades for lots of companies to save money by actually consuming a little bit more storage because the compute is maybe 10x more expensive. This is all predicated, however, on the fact that you have automation and determinism that can help you not only manage it, but also build it in this way. So if you're relying on individualized old imperative scheduling, you probably have no hope. So you should not try and do this. But if you're actually building a mesh with deterministic tools that are are highly automated, then you can have your cake and eat it too. You can have smaller models that are less expensive to operate, but with the support of automation that allow that to be true. So I think from a financial management standpoint, this is really important to think through for sure. As we're talking again through data domains and mesh, I do like to spend some time thinking about and talking through the assumptions that meshes build. And the reason I like to talk through the data mesh assumptions is because oftentimes this is where the trouble spots lie. Like these are the potholes that you're going to trip on as you're building a mesh. So understanding the assumptions and internalizing them and coming up with mitigations or at least strategies to make the assumptions true means the mesh is going to work. Again, if you're assuming something, it means it needs to be true. And if it's not true, you're going to fail. So you need to have the assumptions be true. One of the most important assumptions that mesh makes in all of the white papers, the mocks and pretty much any white paper, is that you actually need to have technology and data domain experts available to you to actually build a mesh. So if I want to build, for example, a customer data model, and nobody in the business really understands how their customer data model really works, or maybe they understand it but can't articulate it to an engineer, and the engineer can't understand the business partner, I'm going to have a really difficult time building a data model that hangs together because my domain expertise is missing. So this is an assumption that's made by the data mesh premise, but this assumption needs to be true for you to be successful. Another one is that, and I've talked about this a couple times, but we'll hit it directly. Data pipeline and data sharing also needs to exist. So the technology, not only the technology, but the automation needs to exist. And so this plays out because if I'm loading data like customer data into a customer model, and that customer data is coming from maybe a call center system, or maybe all kinds of different systems, and I'm accumulating this customer data into a customer data domain. I need to pipeline that data to keep it up to date. But then once I even have this data, I need to be able to share that data. So if I'm in marketing like you, Paul, and I need a list of current customers who have purchased a particular item, like I need to be able to share the customer data over in a way that includes the information that you need from a marketing standpoint, but also in a way that joins it up with purchase history, so you can understand what products they've purchased. I think companies like Amazon obviously are experts in this in spades, but they have this capability built in, not only to pipeline the data in, but to also make it shareable and usable across the different domains. So this is an assumption though that needs to be true. The third one, which is a little shadow assumption, but it assumes that you have a governance strategy that works or that can be deployed. And that means that your organization, one, needs to be able to accept a governance strategy as part of your work. But it also means that you have tools and processes in place that allow governance to be true. I think if you're building something in Databricks and you've maybe heard of Unity Catalog or you've started using it, this is what Databricks is bringing forward as their central governance tool across data. And I think Unity Catalog really will assist in driving a lot of this governance to be a first-class citizen with the rest of the design activities. In my opinion, and in my experience, building a mesh with no governance quickly devolves into a mess from a mesh. So governance is key. And then the last assumption, which is needs to be true, but I chuckle about it all the time, is that every data domain that you use, whether it's customer data or shipment data or finance data or whatever data you have in your business, it needs to have a little minimum maturity level. I don't know how many companies still do this, but a lot of them do. You might be a $1 billion company and you manage your finance on a spreadsheet instead of a database or an ERP tool or something. Spreadsheets are probably not a great place to build a data mesh. So upping your maturity level in the areas that you care to pull into a mesh model is going to be part of your pre-work to building a mesh. So if you have those scenarios, it's important to acknowledge them and come up with plans and investments to improve the maturity level of the data, so that when you build a mesh, it becomes sustainable and it becomes a much better product. And then, of course, once we understand our assumptions, then there are some decisions you have to make when you first start building a mesh. So as we get into the mesh and you start to actually want to build one, these are things that need to have answers to them. You can't wishy-washy around. You actually have to make a decision. And so one is, if you have technology and data domain and knowledge gaps, like what's the plan to close the gap? Are you going to hire a consultant to bring some knowledge in? Are you going to sequester a business person for 6 months? Are you going to meet with them every morning for 2 hours for a couple of weeks till you understand it? How are you actually going to do this as a technology partner? How are you going to engage with your business and or pull that domain information in? And same for technology gaps. What's the plan? What technology are you going to use? Are you going to use what you have? Are you going to experiment? What are you going to do across that? That's a very important decision. Another important decision, and this sounds a little off the wall, but it's not, is are you going to use a standard platform for every single domain? So you're going to consolidate all of your data, for example, for all of your data mesh in Databricks, for example, as a standard platform? Or are you going to have each data domain build its own mesh strategy in their particular platform, and then somehow consolidate the result of that later on, or not? What's the strategy for managing all of this data? I think a lot of people jump to, well, of course I have to consolidate all my data in one place to do this. That's not actually true, depending on the technology you have. But you should actually make that a decision. You shouldn't let that just be an accidental architecture. You should actually plan for that, for sure. And then I love build versus buy discussions, but you should decide, am I going to build this mesh on my own? Am I going to build it with my own tools, my own open source? Am I going to use, Databricks or Delta Lake on its own? Or what am I doing from a technology solution? Or am I going to buy a solution that builds a mesh for me? Or is it some combination, of course? And I think this should actually be a decision. Again, accidental architecture is painful and it's not something you should get into by accident. You should make these decisions and therefore make the budgetary investment and planning and all of the scheduling that you're going to have to do for these projects. You should make that a real upfront decision, for sure. And then whether you decide to build or buy a data mesh, on a Lakehouse. Lots of people just default to I'm going to build it. That doesn't necessarily need to be true anymore now that Ascend is here. But the two things that you need to have when you're building it is data pipelines and data sharing. So having a functional data model for customer is one thing. Actually keeping that model up to date and then actually sharing that data out in a way that's consumable by other people are the two problems that you must solve in order to have a data mesh. Otherwise, you've taken a monolithic data model, you've moved it into a different area in your database and call it a mesh, but it's not actually a data mesh. It's just a refactored data model that's doing exactly what it was doing before, presuming that you didn't have sharing and pipelines the way you needed them before. So these two things are going to be required. So if you're building this, plan for these couple things, and if you're buying it, we can show you some options there for sure.
And
And
John,
let's go ahead.
Sorry, when you say data pipelines, you know, in the context of a Databricks deployment, what would that kind of look like? Is that like is that a notebook that I run on a regular basis? Is that, you know, like how would I actually implement that? What would that look like? What would be the defining characteristics?
Yeah, so let's theoretically say maybe my customer data is in Salesforce, for example. So I have Salesforce Cloud, and I want to use Databricks as my data mesh environment because I have some reporting I want to do out of there. Fine. The data pipeline looks like the software that's going to connect to Salesforce on a regular basis, pull this data down. It's going to curate that information, and it's going to land it into a domain model for customer, right? You could write your own Python scripts for sure. You could use notebooks for that. There's any number of ways that you could build it yourself in Databricks. You can also buy tools to do it. There's like like maybe a CData connector or something that we're partners with that you could buy. But you can also have a platform that's going to include all of the other platform services like Ascend does, from a scheduling standpoint to logging consolidation to Unity catalog integration, and doing all of that stuff in an automated way for you, and so that you don't have to actually write each step along the way. So there's a whole spectrum of potential solutions there. Where you and I obviously are biased toward you should buy a platform for that stuff because it's not adding any value for you to write it yourself. But certainly you could use a notebook for some of it too.
Got it. Thanks.
Mm. If we're going to talk very specifically about Databricks, Databricks brings a bunch of things to bear on a data mesh that are really important for lots of folks who want to do a data mesh. One, of course, is Unity Catalog can be a central point of governance for the data that you're going to put in a mesh. So this is the place where you're going to stage information for sharing activities outside of Databricks, and do some security work, do some catalog work. You're going to use Unity Catalog for these things. And Databricks is making significant investments in the Unity Catalog, and they're continually improving it. So even if it doesn't do what you need it to do today, I'm certain in the future they'll be adding quite a few things to it for sure. Databricks is also uses cloud native technologies like Delta Lake, sorry, which lend themselves very well to data mesh architectures, in that you can have many things in a Delta Lake. It's highly parallel. You can load it. It's cheap to store information in a Delta Lake. You get all of this capability like cloning and all these other capabilities that you can use. So it's very nice for doing data meshes at scale when testing becomes important, and some of these other topics. Databricks also does a great job of allowing you to use multiple languages. So you can use SQL and Python basically together. You can write SQL, you can write Python. It does it in an elastic way, so you can define how much compute to consume. You can limit it, you can unlimit it, you can make it unlimited, but you have all this capability around executing the queries that you're going to need to execute. Databricks can also be scripted, but it's also secure. So it brings all of these, this is just a few of the facets, but it brings a lot of these things together into a platform that allows you then to not have to worry about how is my data actually being stored, or if I have consumers that want to do data science in Python, but I have consumers that are SQL savvy, I can service both of them on the same platform with Databricks. So a very nice, in a nice way for sure. When you start to look at, okay, what about Ascend on Databricks? Ascend is bringing the extra layer of platform services on top of what Databricks is already providing. So on the left side here, we have bunches of data sources. Name them. You name it, and it's available. And then on the right side, you have all these destinations, some of which might be reporting tools, some could be, reverse ETL jobs back to Salesforce, for example. And then Ascend is providing the ingestion and transformation activities and this deterministic scheduling, so that you can have your cake and eat it too. You can have many data domains. They can all be managed for you, and then they can also be shareable and secured in ways that are useful. We'll talk more about that in a minute or two. So Ascend ends up being this end-to-end intelligent automation platform. So just to summarize, meshing Databricks with Ascend on Databricks. Unity Catalog is automatically integrated with Ascend. Ingestion is gapless, so at scale ingestion across pretty much, or not pretty much, any data source is possible. Data sharing is super simple, like 1 or 2 clicks, and you can share data between an engineer and like maybe a data scientist. You have polyglot language, so you can use SQL and you can use Python, and you can use them in the same pipeline. You can go back and forth between them, so you can do machine learning right in the middle of regular SQL statements. Integrated quality controls, so that you can put in rules for what your data quality should be all the way throughout the entire pipeline. So from ingestion quality all the way to final delivery, this report needs to be perfect, and here's my quality rule, and I can stop it from happening if I want. Ascend provides that in the platform. Of course, then observability is critical. How much is my pipeline costing me, and how much, if I'm doing showbacks to business partners, which pipelines are costing what, and how do I divide up the cost of my Databricks compute fairly across all of my consumers, which may be business units. At an enterprise scale, typically that's true. And then finally, not finally, but like the last one on the list anyway, how do we drive agility? So how do we get not only all of this really good stuff, but how do we do it in a way that allows me to have source control integration with CI/CD and workflows and controls for compliance and audit and other enterprise quality or enterprise needs when I have multiple developers working on the same platform? How do I know it's all going on properly? Driving agility through automation in the workflows is critical. So Ascend provides all of this additional functionality while still pushing all the work down to Databricks. And then, of course, the last piece that I'll talk about here with Ascend on Databricks is that we also support multiple instances of Databricks. So if you have multiple cloud instances of Databricks, you can share that through our live sharing across instances of Databricks. But then if you have data in other databases, maybe you have a large marketing database in GCP that you need to clean up and share into your Databricks environment, but you also have maybe finance in Snowflake, and you need that data in there also. Ascend provides this live data sharing across all of these environments that not only moves the data on a regular basis in a controlled way, but also notifies you for schema changes and other activity that may be happening, in different platforms that Databricks can't see. Ascend provides this this bridge across the different platforms so that you can actually share data across them without having to fully migrate data. So it makes the data mesh assembly process much cleaner and simpler across multiple sources. And then the last point about building a mesh on Databricks with Ascend is that because Ascend is providing not only the end-to-end efficiency of only having a single tool across all of that, in addition to Databricks, though, a single tool, but we're also really good at consuming compute when compute is needed and not consuming compute when compute isn't needed. That means that in general, customers can spend less money and get more work done using Ascend because we're not going to redo work that doesn't need to be redone. We're super good at not only ingesting data into Databricks in a very efficient way, but also as you're processing pipelines downstream and making changes and running your business, you're not going to reprocess data that doesn't need to be reprocessed. We can do mid-pipeline restarts. We can do all kinds of interesting things that save compute downstream, both for SQL and Python across both of those. And then because the platform takes over things like Unity Catalog integration and makes CI/CD really easy and does security really easily and does all of these things that engineers would normally have to do, it means that they have more time. Engineers and frankly data scientists and analysts have more time to actually do engineering work. That means they can manage more pipelines because they're very much focused on business rules in transformations and executing on the business needs and spending way less time, if not zero time, managing log consolidation and connections to databases and like all of these other activities, which are even creating tables, which are toil-based activities that don't directly result in business value output. So much less expensive on the tooling side, and you get much more efficiency out of engineers. So if you're building a data mesh, you could expect a mesh to be built much more quickly on Ascend than you would build it by hand. Analysis work aside, there's no magic there. Somebody still has to figure out what the model looks like. What do you think, Paul? I think
makes sense.
I think
I love it.
Yeah, it's a great topic, and I could definitely keep going for quite a while on it.
Yeah, I wanna save 7x of our time that we spend on that kind of stuff.
Yeah, that would be fabulous, wouldn't it?
Yeah.
Yeah, for sure.
Good stuff.
Yeah.
Great. Well, thanks for that, John. That was super insightful and a really great primer kind of overview for the audience to think about when they're thinking about all aspects of implementing a data mesh on Databricks. This is the part of the program where you can ask us questions. So you'll find a little Q&A option in your Zoom chat window. Please feel free to drop any questions in there if they come up. If there's anything you feel like we didn't cover or you have open areas. But John, I have a question, and I realize that this might devolve into a massive philosophical debate that might take more than 3 minutes. So apologies in advance. But for those that have maybe been around for a while in the data modeling world and data warehouse world, that kind of stuff, in your mind, what are some of the differences between a data vault and a data mesh? In terms of how would you kind of compare those two things?
Yeah, I mean, I think a data vault has a very defined structure that you're implementing in order to call it a vault. There's a very defined way to build a data vault versus a data mesh is going to be much more strategically oriented in that we want the data mesh to reflect the way your business operates. And so the models that you're building are essentially images of how your business wants to operate. And this reduces friction with your business partners. This increases trustworthiness of the data. But it also means that everybody has their own take on it because every business makes money their own way. They have their own secret sauce, which ends up in a model somewhere. And so I think as far as designing a mesh, there's some principles that you follow, but it's very much about making friends with your business partners and figuring out why your business makes money and reflecting that in a data model that works for you. Versus a data vault, which is much more structured and even the way the keys are set up in a vault, like it's very like kind of locked down, which is I think why they call it a data vault. So I think I've gotten the confusion between those, by the way. But data vaults are very popular in like financial services, places where the actual movement of data has serious consequences. But yeah, data vault
Yeah.
applies for sure. It solves the problem.
Yeah.
I think for most companies, a data mesh is just fine.
Yeah. Makes a ton of sense. And you probably don't have to go to a 3-day boot camp for just to learn how to do a data mesh, right? Compared to a data vault.
Yeah, and in fact, if you had happy hour with one of your business partners who was like the domain owner of the area you're interested in, and you got out a few napkins and a pen, I bet you come up with a pretty decent data model over a couple of beverages, and it wouldn't be too far from correct. I mean, you need to put a little of the technical stuff in it later, but as far as meeting the business need, it's much less complicated than it seems in a lot of cases. The
Well,
things that
that
I wish
takes us.
in healthcare, well, I was in healthcare for a while. Some of the things that I wish I had done, and now I would do if I was actually driving like a claim model, I would have separated out all the pieces of healthcare claims, like so diagnoses and procedures and finances, and not just like loosely couple them, like make them separate domains and then worry about recombining them later. That would have taken a 700 table model down to like a dozen tables per, and it would have cut down the amount of like business knowledge required to use it dramatically. It would have actually been approachable and usable. So that's just a personal example of how some of this monolithic thinking tends to drive up complexity. Whereas if you just sit down and kind of sketch out kind of what you want and actually make that true, and then have real business keys that work instead of surrogate keys, it tends to make it much simpler to operate.
That makes a lot of sense. Yeah. And you can also imagine that customizing the data models to the business can only add tremendous levels of value, right? Because your business is unique and competitive because of the way that you operate, right? And so if your data fits that versus your business having to fit into the data model, then you can imagine you're just leveraging your strengths.
Yeah, absolutely. And I have if you follow me on Medium, I have an article on how to talk through that. And I use a 2x2. One axis is business differentiation in the market, right? And the other is business value generation. So if you prioritize your work in the upper right corner, which is highly differentiated and highly valuable, that's where your engineers should be focused and spending most of their time because that's where your business is making money. Anywhere else on that 2x2, especially the bottom left, where it's not differentiated and it's not creating any value, you shouldn't be spending any time on that. So this is why nobody writes their own HR system. Like you should buy an HR license for an HR system. You never write your own software. So then the question is like, why am I writing my own data platform if my business is like analyzing MRI imaging? Like my secret sauce is in the software that does that analysis. The rest of the pipeline stuff, I should be buying all of that because I am not a software company. I'm an MRI imaging company, for example. So
Yeah.
those are ways to aggressively think through like how do I go faster? One way to go faster is to think that way through how you're managing your people and your dollars and where you're actually spending it.
Absolutely. That's great. All right. Well, thanks for that, John. That was a great session. Some really, really great information about how you can drive enterprise-wide adoption of your Databricks Lakehouse using data mesh. If you have any questions that kind of span the duration of this webinar, please feel free to reach out to us at ascend.io. We're more than happy to continue the conversation with you there, show you a demo of what a data mesh could look like on the Ascend platform for your organization, and as well as continue the conversation on anything else that you have with regards to implementing a data mesh. But thank you all for joining, and specifically thank you, John, for taking the time to put all this together. It's been great.
Yeah, my pleasure. Thank you. Thanks, Paul. Appreciate you scheduling it.
Sounds good. Have a great day, everybody. Bye bye.